Okay, so before we start getting into the meat of our presentation, let's quickly introduce ourselves. My name is Alicia. I'm part of DCSO with Drawer. We'll tell you a little bit about the company in a bit. All you really need to know about me for this talk is that my background is mathematics and data science, so only a sprinkling of cybersecurity, which Drawer brings to the table.
Yeah, so, and I'm Drawer. I have a long history in security. A couple of people know me. I recognize a couple of faces in the audience. So I've been doing this for the last around about 20 years. Have been part of ER&W in the early ages of ER&W. By training, I'm a geophysicist. So we have a mathematician and a physicist here trying to do something with data and security. To give you just one little background slide on what we do. So DCSO is a rather newly founded company. We are 3 years old. We have 4 shareholders, big German companies, and we provide security services and a platform for sharing, collaboration, where they all come together. Not only the shareholders, but it's a much larger community. And while we do provide services, we are not aiming at maximizing profit. We are trying to make money, to pay wages, and to do good. So that's basically the story behind it. And there's like 3 important parts for this presentation. Is we do incident response, especially in so-called APT cases. We provide threat intelligence, and we have developed a network sensor which we place in customer environments and try to monitor for security threats. So that's basically what we do. We do more, but that is the part that is really important for us. And when we look in our community, customers, like the companies we work with, they face all various types of threats. It can be criminals, cyber criminals, can be Five Eyes, can be bears and kittens and whatever you want to call them. All of these are of interest to us. Basically, it's very much driven by our community. When they say we have an issue with Chinese espionage, so this is our issue then. And when our constituents say, look, we are operating in Iran and we are involved in whatever gas and oil extraction, obviously then you're in the focus of the Iranian threat actors. So that's basically the actors of interest for our, where did it go? Wrong button, sorry. Right button. What we are talking about here is our solution of monitoring networks for threats. So we built a sensor. It's based on Debian. There's a lot of open source in there. The main detection engine is Suricata, and there's a lot more to it. And we contribute quite a lot to the Suricata project in code and bug fixing and improvements. And these sensors can basically operate with Suricata rules. They can operate with Yara rules. We do file extraction and then can do Yara magic on files. And with the traditional indicators of compromise. So we analyze network traffic and looking for IP addresses, domain names, URLs, all that kind of stuff, and can alert on that. So that's basically what we are trying to do and how we operate. So when we look at that, for the scope of this talk, we were trying to find threat intelligence, and there's a lot of discussion out there what threat intelligence actually mean. So I'm going to scope it down for this presentation. We are actually looking at indicators, Yara rules, Suricata rules, the stuff that our sensors can work with. That is basically what we are focusing on. And again, I need to find the right button. There has obviously been a lot of work done in the past, most notably probably the Alex Pinto, Kyle Maxwell work, the TIC test, threat intelligence quotient, TI TIC test. A couple of good presentations around that. I just took a picture of the presentation from the DEF CON on the left. What they did a lot of measuring overlap between different providers, like how many IP addresses that I received from provider A did I also receive from provider B? And what is the time distribution between the overlapping information that I had? That is quite groundbreaking work. I like it a lot, but it's actually not trying to answer the question of what is in the data you get. It's comparing data, but it doesn't tell you what is in there. Another thing which is quite interesting is a paper by Pavel Pawlinski and Andrew Kompanek, so that's more from the third perspective. They did like long-term studies, mass data, again, comparison of overlapping and also like time distribution and evolution over time. Again, not so much answering a question of what's actually in there, but that is actually what we want to have a look at. If we look at the pyramid of pain, if you're into threat intelligence, there's a sort of pyramid of pain. There's the easy stuff, like IP addresses, domains, and things like that. There is the difficult stuff, like how do they actually operate? So the TTPs, and then there's the very hard stuff, like why do they actually do that? So in our case, we are still looking at the bottom layer of the pyramid of pain of threat intelligence. So we're aiming at the low end, at the low-hanging fruits of trying to do the easy stuff, like getting decent IP addresses, getting decent domain names. We were not aiming at higher levels of intelligence at this, in this project. And again, maybe to just scope it a little bit more, Alicia is going to tell you about the sort of detection and APT side.
Yeah, so like George just mentioned, a lot of the research was more on comparing providers, but without any specific focus. And our focus here was really APTs and how can we improve the coverage of our sensors for our customers. So we decided, okay, let's do this. Let's basically start from scratch and see if we can answer this question. And I think we knew it was a hard question, but I don't think we knew just how much pain it would cause us. This is how we felt for, I think, 75% of the project. And that's kind of why we're here today. We want to talk about what we found difficult so that hopefully you don't have to go through exactly the same pain we had. And hopefully at the end, we can also discuss what could change to make answering these kinds of questions and related questions easier for all of us in the community. So without further ado, let's start with the painful stuff first. And we will talk about some of the results we found at the end too. It's not going to be totally depressing, don't worry. Right, the challenges. These were, I would say, the key challenges we found. So the first one was best. Like how do we actually define what is the best threat intelligence provider? Another challenge that we'll go into is how do you actually define or how do you qualify an IOC as being APT? Next, how do you design a controlled experiment to compare provider A against provider B against provider C? A particularly painful one was standardizing the data in order to compare them. And finally, timestamps, always a big issue, and we'll get into that in more detail. So starting with the first one, best. What does best mean? So for us, it really meant it has to fit our purpose. So best for us probably isn't best for you. And best for us meant it needs to, well, first of all, it needs to improve the quality of the coverage on our sensors. And for that, we're interested in the following things. So things like low false positive rate. So false positive rate is a tricky one, and we can perhaps explore some of that in the questions later. Obviously, if you talk to a provider, they're going to tell you we don't deliver false positives. That might be true in the context of what they're doing or what their intelligence was designed for. But for us, the aim is to put these IOCs and the rules onto our sensors, which are then going to trigger alerts. Those alerts are going to be, they're going to go through some machine learning systems, but at the end of the day, there are also some human analysts that are going to be looking at the alerts that result. So it's in our interest that we're only really flagging indicators that are really malicious or, yeah, particularly malicious for our clients. Next, something we're also interested in is high quality context. So how much information is delivered with the indicator. We ideally want more than this is an IOC, it's bad, block it. other things quick to publish. So what we mean there is how quickly an IOC is delivered has a huge impact. So yeah, I mean, and we'll explore that one too. I mean, the point there too is if you're delivering something very fast, then obviously it might have an impact on your false positive rate because there's a larger chance of an error. But if you deliver it too slowly, maybe with lots of additional contacts, maybe it's too late. Finally, expiry dates, again, related to the context, what goes with the IOC. Machine readable was particularly important for us because at the end of the day, the IOCs weren't meant to be consumed by our analysts. Obviously, we had people in the company that were really excited about the data that we were inspecting, and they wanted to get their hands on it. But the first aim of our project was really the sensors, and the sensors need something that's machine readable. And finally, maybe the trickiest thing of all, labeled data, but Dror will say something about that in a second. So quickly, just to highlight, from the sensors perspective, those were some of the key dimensions that we're really looking to optimize. And I'll pass on to Dror.
Yeah, okay. This was actually my first ever project with a data scientist, so I learned a lot. It was a very interesting and enlightening experience at the end of the day. So I said I want to know whether an IOC is APT. And APT basically means it points at an infrastructure, a piece of malware, something that has been used by an APT type of actor in the past, or even maybe is currently actively being used. That is how I approached the project. And then Alicia said, look, yeah, well, but I need a label in the data that tells me this is APT related. But it's not about labels. I have an indicator, and we want to work with the indicators. And then Alicia said, yes, but I need a label because I need to classify it. If there is no label, I don't know whether it's APT. And then I said, oh, look, but if we just go by the labels from a security perspective, we are not actually judging the indicator, but we are judging or evaluating the vendor's, the provider's capability to label his data. So this is really a tricky one if you start thinking about it. So from a security perspective, actually what I want to have an indicator, IP address, domain, URL, you name it, I don't care. And then I want to be able to judge whether that is malicious or not. And if it is malicious, I want to understand like what kind of threat is behind it. It's like criminals, it's Chinese, state espionage. Is this historic? Is this current? Now, if I get data from a provider, the provider is responsible for putting all that kind of context, like where does it belong to, into labels. And so when I start comparing labeled data. I'm not comparing the data itself, I'm comparing the labels. And I'm not taking a decision on the data, I'm taking a decision on the labels. How much do I know about how the provider is labeling his data? Nothing. It's the magic secret sauce black box that they're not talking about. So this is, from a perspective, actually quite frustrating, and it's a not yet resolved issue. So keep in mind, whenever you do this kind of thing, you work with labels, because there is nothing else you can do at the moment.
Maybe just one thing, I mean, it is possible to work without labels in data science, but the complexity of APTs makes it extremely hard. I mean, you're not really working with masses of data that has been labeled in the past that you can reuse in order to create a system that automatically flags something if that's APT because it looks similar to something it's seen before. So just to highlight it, I mean, this is an assumption that we had to make, and it was something that we had to agree on together. Okay, for the for this project, we're just going to agree that an IOC or a rule is considered APT if there is a direct mention to an APT actor in its metadata. And it's definitely something that, like George said, not everybody was too happy with that definition, but without a definition, there was just no way we could proceed and end up with a result.
No.
So data formats, which was another challenge that we mentioned. Our hope when we went into this was, so we're big fans of MISP, and we wanted to ingest the data from the different providers into the MISP and then use some of the features. For example, you can correlate indicators. What we didn't expect was just how difficult it would be to translate, let's say, the data coming from the different providers into sort of a unified format. So in some cases, we were lucky. We worked with a few providers that provided their data via MISP. But in other cases, we were working with sticks or like other JSONs coming via APIs with, yeah.
Nested XML.
Nested XML, I forgot
That was the most awful one, was like multiple nested XML contained in zip files, transported via HTTPS, which used client-side certificates locked to an IP address. Not joking here. This is serious. I'm not exaggerating. I mean, that is the kind of sort of transport which comes before you even get to the data. Sorry to step in.
No.
Right? So it's awful. It takes a lot of engineering.
Yeah. So we thought we'd share a few examples. So this was kind of, those are excerpts of two different providers, and that's kind of the ideal scenario. You've got an IOC, and in it, like, it's telling you, okay, the type is a threat actor, or in the other case, is telling you like what the threat actor is. And actually, in the first case, they also tell you in a different tag what the actor is. So there, you can parse that. Awesome. What you have in other cases is perhaps maybe here you can at least see, okay, they're mentioning a threat actor, but there's no standardization, and the tag there is info. So info can be anything. So what you end up doing there is writing some sort of custom string parser, and I guess you're all familiar with Florian Roth's spreadsheet or Google Doc online, where he has the different countries and the different threat actors and all the different namings from the different providers. So we did like this custom mapping in order to parse the strings. But obviously, you're going to miss some, and you're probably going to get some things in there that shouldn't be there in the first place. Then there's also this case where here, this is actually two different providers. They both had this timestamp field called timestamp, but it's not the same thing. And sometimes it's not even clear from the documentation, because they're using maybe the same protocol, but then you ask them and they're like, oh yeah, but we actually, that gets updated every time we make a change to the event, or oh yeah, that's actually the created at, but you probably want to use a different timestamp, which is in a comment field, which is obviously a string, which you then need to parse. So don't take anything at face value is maybe something to keep in mind. And
maybe just yet another example. All this timestamp, time-based information, it's really awful. So one thing that a couple of providers give you as a timestamp is a first seen, but there is no really good definition of that. So let's have a look at what it actually means. So there is a time flowing from left to right? And there's this infrastructure which is being used by a threat actor. Well, nothing uncommon. And it's in use. And at some point in time B, some researcher, provider, whatever, discovers the activity and says, oh, look, I know about this infrastructure and what's going on there, and research is going on. And at some point C, then the results are being pushed to customers. The infrastructure may still be up and running. Maybe it's not up and running anymore. But we now have at least 3 different times. Like C is the time the information was given to the customer. So it's like first seen by customer, right? B is the timestamp like first seen by a researcher. And A is a timestamp like the first detectable trace of its activities. And there is no clear definition when a provider gives you a first scene, whether he means A, B, or C. And then he gives you like updated at, created at, changed at. And don't think that if you get any like updated, created, or changed at timestamps, they tell you what they changed. It just tells you it changed. And then you need to make sure you have a copy of every single instance of the data in order to sort of diff and figure out, did they change the attribution? Did they change like severity ratings? Did they just add additional context? All of that is not clear if you look at these sort of timestamps, and first scene is just one example of that. There's more timestamps to come, I'm sorry. This time issue is completely broken.
So you kind of already mentioned it. On the left was one provider, which, I mean, also, despite the fact that things might not be clear, okay, what exactly is meant with last updated, that's ideal. You know, they've got different timestamps, they're labeling it clearly. On the other hand, you have some provider that might just say date, which might be fine for the context where they, you know, maybe they publish reports and that's kind of fine for them, but if you're trying to make an experiment where you're trying to figure out, okay, who published first, or who found this IOC first, that makes it difficult, let's just say that. So again, we had to make an assumption, and this time it was the earliest timestamp associated with an IOC is the time when the IOC was first discovered. Now we know it's not true for all the providers, but if you can't, you're better off making an assumption and being aware of like the bias and what you've done in order to get to the result than discussing it or just stopping and not getting anywhere.
Yeah.
And then back to drawer.
Yeah, maybe another.
Oh,
yeah.
Did you want?
Yeah, fine.
Yeah,
Yeah. Another example of it's not a timestamp issue, but also a temporal issue. So basically, we were trying to test various providers, and obviously, from a sound scientific approach, being a mathematician, Alicia, and being a geophysicist myself, so we are both like, let's do this scientifically correct. You try to align the providers, and you know we all know there's like some negotiation, NDAs going back and forth, and then they give you access, and one gives you like access for 4 weeks, and the other one gives you access for 6 weeks, and things like that. So you'll not have a perfect alignment, but then you try to find like the maximum common time, and you say, okay, I do my comparison based on this common sort of time frame. So that's the theory. In practice, the alignment actually looked like this because it was impossible to get them at the same time. I mean, we tried really hard, but then it's like, you talk to the first one, and the first one's like, ah, yeah, you want to test? Here's your account. It runs from now 2 weeks. And we say, no, stop. We want to have it later. No, it's running now. It's gone in 2 weeks. You have to do it now. And like the next one is needs 2 months of legal paperwork in order to give you access. And so you have there is actually no chance, I believe, of aligning providers in time. So this is how it actually looked. And then there's the question, so which data do you take for comparison? How do you do that? That is what we looked at. And that's how we felt. We're like, oh man, is our experiment broken? From a scientific point of view, I would say, yes, the experiment is broken at this point in time, and it does not make sense to compare anymore. Now, we are not in science. We are engineers, and engineers, tend to be practical, and we need to get a solution. We need to take a decision. So what we did was that. Covering a little bit of data here, covering a little bit of data there, and we all know it's flawed doing it like that. You want to go to the results?
Yeah.
Yeah.
Okay.
So
I think that's enough of the heavy stuff.
Yeah. Frustration.
Okay. So now let's talk about what we were able to observe. These were the providers that we considered at first. But like we said, I mean, the various challenges that we encountered, lining them up in time, even though we did make some adjustments so that we didn't kick everyone out, otherwise we'd have nobody to compare. And some other things, like, for example, making sure that we had labeled data without labeled data. I mean, that would be a whole project in itself, trying to figure out, okay, is this IOC APT or not? So we decided in some cases to leave the provider out for that reason, because their data wasn't fit for our purpose. We ended up with this. So we can't actually tell you which ones we analyzed in depth, and we definitely can't tell you which one we ended up going with at the end. So for the purpose of this presentation, I hope apples and pears and oranges and bananas will be okay. And yeah, just to recap, I mean, as we're going to go into some more of the analytics, what was best again? So best for us was low false positive rate, quick to publish. We also had like an interest, like George said at the beginning, I mean, which threat actors we were interested in. There were some in there that were of particular interest to us, so we're kind of keeping an eye out on geographically, okay, which provider is focused on these areas. And also, I'm trying to remember all the, okay. You can always go back. I mean, there were like a few key dimensions that we were keeping in mind. And here, I mean, we're not going to show you any numbers because we can't, like we said, unfortunately, we can't share the analysis we did. And we originally actually went into the project hoping that we could at least share the code so that you could run it yourself with other providers. But unfortunately, there was so much custom code to like try and fit the data from one provider into like a table that we could then compare with data from the other provider that unfortunately we can't actually share it, but we'd be happy to talk to you perhaps one-on-one afterwards. So this was an example of looking at the false positives. So we have internal lists that, well, our analysts have created that we use on our sensors and that we use to sort of for our own research, and we use that to compare, well, we checked the IP addresses, domains, and URLs specifically. I mean, there were also file indicators, but our focus from the center's perspective at the moment was mainly on network indicators. And yeah, that was one way at least of getting a feel, okay, maybe we need to look into so the Apple provider, why are we getting a lot of false positives there? Or what kind of domains are coming up for the oranges? And in some cases, it's not actually like, oh, there's lots of false positives. That's really bad. It's more a case of, okay, what have we not understood about the way this provider creates their data? For example, maybe there's a lot of contextual information in there. Like maybe they're linking to a Twitter post or a blog post, but somehow it's formatted and in the same way that they format their indicators, and that just got pushed into our system. So this is more like an exercise in figuring out, yeah, what are the false positives? Like, definitely don't stop there. Look into what your false positives are.
Yeah, maybe just to give you a couple of examples, obviously on the IP addresses. If a provider tells me about RFC 1918 IP addresses being malicious, yeah, I know it's all my systems, they're all infected, but no, honestly. So part of the high IP address count is actually from RFC 1918 IP addresses being reported as malicious. Example of domains. There was one provider who repeatedly reported example.com as a malicious domain. URLs, also quite interesting. I mean, that's what Alicia already mentioned. I mean, that's actually a machine problem in here. If a provider publishes information in a JSON and it puts a lot of contextual information, like this was first reported in a Twitter feed, in a Twitter post, and then puts in the twitter.com/username/ID of the post, and you have this URL. Then what happens is a machine then parses this, breaks it down into multiple pieces, like there's a domain, there's the protocol, HTTPS, then there's the domain, and then there's the URL, and a machine then puts it into different parts of the XML file and distributes it all over the place. And then you have like twitter.com being malicious, you have the whole URL being malicious, but it was just a sort of hint for a human reader, a quote like it had, this information had been published somewhere else. But it ends up as indicators in the data the provider gives you. It's just failure. Things like that just happen. Sometimes, and especially with IP addresses, there's also another thing which is quite interesting. The question is whether you, we simplified this a little bit in here. What do you do about IP addresses that you know that are sinkholed? So we keep our own well-curated list of sinkholed IP addresses out there. Probably everyone does. If a provider gives you information on, this is malicious, this is very critical, the world is going to collapse, burn down, and then you say, but it's sinkholed. How does it change your own sort of classification of the data? I mean, yes, it is malicious, or it was malicious in the past. And if you see a connection to that sinkholed IP addresses, yes, you probably do have a problem somewhere and you should need to investigate, but it's not the world is going to break down in pieces. So that kind of thing we also put in the false positive, because it creates, at the moment, for us, too much noise looking at everything that is sinkholed. So be cautious about that. Be very aware of what you classify for yourself as being false positive. There is no one truth of false positive. Very important lesson in here. It depends on what you want to achieve. It depends on it's like, are you in a hunting exercise? Are you in a monitoring, like 24/7 situation? And you'd have come up with very different definitions of what is actually a false positive. So that maybe going into a little bit of detail in here and giving you a little bit more of context of what we try to achieve.
And one of the things we were interested in as well, like I said before, was geographically, what threat actors are they focusing on? So on let me see if I can use this now.
Pointer.
Yeah, okay. So here were the main countries, nations we were interested in. Oh, a little bit of formatting there. Unfortunately, we included unknown and, oh, yikes.
China, I know that's fine.
Okay.
It's just very light gray.
It's very light. Okay, I was wondering. Okay, so for example, other countries that didn't fit into those top 4, and unknown were things that were classified as APT in some way, but we didn't have any way of relating it back to an actor that we know about or that we could easily find information about. So for example, here you can see that pairs are specifically focused on network indicators in China. Here, okay, we have China again. Here, Iran, for example. So this was, I think, at least from a management perspective, quite useful graph in order to make the final decision, okay, like which provider here is the areas that fit our purpose.
Yeah. There's another quite interesting takeaway in this slide. If you look at the apples, you see a lot of unknown files. If we can just skip back to the 10 sort of providers we had in the beginning, you will notice in the beginning, like a couple of slides. Yeah. Just go back to these. Yeah, that one. Yeah. Yeah. You see there's like at least 3, let's call them traditional antivirus vendors. What do antivirus vendors do? They create signatures for files, right? And that data is then reused and sold for a lot of money as like threat intelligence. So when we look at this comparison of the 4 fruits, it is very obvious that one of the traditional antivirus vendors is Apple's, because they provide you with, if you go back to all these file hashes, and they don't put any sort of relevant information around it. So this is just waste. It's like, it is automatically generated waste, which they sell you at a very, very big price. So basically, it's useless crap at the end of the day. Sorry to say, for us, it's useless crap. For us, in our project, right? Your mileage may vary. Yeah, but this is actually as Alicia mentioned, from a management perspective, actually the most important slide, because it gives us the opportunity to increase our coverage. You know, for example, if we know that, you know, our constituents are very concerned about Chinese-run corporate espionage, then obviously going for a provider which gives you a lot of information on China, which can be used on network sensors, fits our purpose. Right? So that's the way you need to read this graph. Again, I find it quite interesting that there is like one provider, obviously quite focused on Iranian activities. One provider very much focused on Chinese activities, and then there's like the top left, the orange is one which seems to be, well, sort of dual focused with a Chinese and Russian activity. If you're in the threat intelligence space, you can play the interesting guessing game. So you have like a 10-to-4 matching, and if you know a little bit about the background of the providers, you probably will get around about 80% right in here. Yeah, but obviously for NDA reasons, we cannot give any sort of details into that. Even though we went through all the pain that we had explained, we actually were able to take a decision based on these results. And so let's put up the good one.
So just say there are more results than this, but
go ahead.
I just want to say, like, we also, I mean, we looked at other things, for example, overlap, like the previous researchers did. We also looked at like the timestamps and who, based on our definition of what discovered means, like who discovered the IOC first and shared it first. We also looked at like where the IOCs came from, like for example, were they also, are they part of open source intelligence, and are they then being repackaged by the vendors? I mean, those are all things we considered, but they're things we decided not to show.
Yeah. So we're limiting what we are showing here. Okay. So.
You were going to say something.
No, I'm fine. Okay. Thank you. So before you.
Yeah. So we were thinking of doing something a bit different today and going into the Q&A now and then sharing our final thoughts after the questions. So maybe we can have 5 minutes of questions.
Yeah, at least. Yeah, around about 5 minutes of questions, and we'll do some conclusions and final thoughts after Q&A.
Hi, my name is Henrik. Did you see any threat intelligence distributors that were not having their own research, but just like reposting others they collected?
Yes.
Are there the really bad ones out there?
Yeah. This is especially the case if you look at Yara rules. So we didn't have any statistics on Yara rules in here because most provide you with only very few. And if you then look at them, I mean, if you know a little bit about Yara, it's also difficult because you write Yara for a specific purpose. So Yara is a difficult topic. But we found that most Yara rules being shared are, let's say, based on Florian Roth's public collection, right? So there's like one single source of truth for Yara. At least it feels a little bit like it if you look at that. Then everyone sort of includes the open source stuff of the Tor exit nodes and things like that. So there's like a common, I would call it, it's like common gray noise that everyone has, which you can just get by, for example, running your own MISP instance.
Yeah, first, thanks for sharing these insights. I don't want to open your wounds again, but one more question regarding the difficulties you had. From what you're seeing and what you might see in the evolvement of this, is there any insight you got into how these providers got their intelligence, or whether it's data, information intelligence, and what their possible biases are and their methods? So we can go one step further with figuring out actually what might be false positives?
Not really, because that is the magic secret sauce, and they're not sharing magic secret sauce. Obviously, they will all tell you statistics, things like I am an AV vendor. I have 500 million installations worldwide. These 500 million installations worldwide have the greatest coverage. We see everything, we know everything, and that's where we get the intelligence from. Then you have the network-based vendors. They say, oh, we monitor 95% of the internet traffic. We see everything. And we see a lot more than what happens on the endpoints, because there's all the stuff that's not happening on endpoints. And therefore, we have the greatest, best coverage, and we have the best intelligence. Then there are others who say, our history is we are that close with three-letter agencies, and our background is in securing nation states. And therefore, we see more than everyone else, and our intelligence is the best. If you look at overlap, actually, and now I can't remember all the details, but the thing is, if you take away the sort of open source stuff and do, and maybe we should do that experiment. I'm just thinking about this. Like, we don't have the data anymore. That's part of the problem. But maybe something for you to do in the future, if you do something like that. Delete the open source stuff and do the overlap only on what's remaining. My assumption at the moment is there is very little overlap. So everyone is contributing something, but no one is contributing everything. And that's part of the issue in here.
I think there was also an argument to be made that if they're, even if they're sharing something that's been shared by someone else, I mean, they might be adding more context to it and it might fit. I mean, it's not necessarily all bad either.
Exactly. I mean, same, like just having it in a single format through a single API already provides a value if you don't have to collect it yourself.
So just as a quick follow-up, what would your rating be on a maturity scale of some of these on like 1 to 10? How mature do you
Zero to 5 on a 2.
0 to 5? I would say the best ones were maybe 7 or 8.
Okay, I was on a 0 to 5 scale.
0 to 5, 0 to 5.
The traditional CMM, the traditional management CMM model.
Okay.
0 to 5. I would put them at a 2.
5 being best.
5 being best.
Okay. Yeah, 3 maybe. I mean, yeah, average might be around 2.
Yeah. We are bad.
More questions?
Hi, how are you? Thank you very much for the talk. I wanted to know, these questions that you are doing, like, hey, what's going on with these IPs, what's going on with these URLs, where are coming from, which is the ultimate goal that you want to achieve? Yes, the first question one, which is the best provider, but what for? Are you willing to increase detections, decrease errors, coverage? Like, what is the measurement that you're trying to optimize? Because most of the questions seems to be related with that, right? Where do you want to go?
We run these network sensors in customer environments, and we want to detect more while not having our analysts look at all the irrelevant alarms, and detect more in the space of nation-state type threat actors, which are relevant to our customers and community. So that's mostly China, Iran, North Korea, Russia. Let's put it like that.
So when you say detect more, well, which is the measurement that it's restricting that? Is the false positives? Because of course, more can be you put everything and you detect a lot.
Well, there's obviously there's technical limitations. How much can you put on a sensor to look for? There is financial limitations. If I have all the money in the world, I could just buy everything. I wouldn't worry, right? And there is the processing and human analysis part of that, which is also, so there's a lot of limiting aspects. Yeah, you need to optimize between investment, effect on technology, on the technical stack, performance, and effect on human analysis. Find the sweet spot.
Okay, thank you.
Yeah, don't run out of time. Okay, yeah, but we're good.
Yeah,
It's
Maybe just a brief question on the ethics. I've heard a lot of discussions whether threat intel could be consumed from rather unethical sources because they would actually support and be valuable for industry, for all of us. What's your opinion on that?
what's an unethical source?
Exactly. Like, if I say darknet, I get killed. So
Yes.
I'm not saying that. Yeah. So that's definitely not the right definition. The question is like, let's say someone gained or caused certain TTPs, which are definitely, let's say, illegal from a legal perspective. Which
Well,
probably like 90%
illegal is easy.
most of it. Yeah.
Illegal is very easy.
Right.
I mean, then you can say, okay, if
So,
it's illegal,
yeah.
we don't
So,
do it.
Yeah. So you're saying, for instance, let's distinguish between people like trying to make just monetize their attack, with ransomware and stuff like that, versus people actually targeting chemical plants to really cause, like human damage, health, environments, things like that. So I would say there's a difference whether you want to get rich by being a criminal, or whether you actually want to hurt people, hurt plants and stuff like that. So I could imagine there's definitely
Maybe we can come to that at the on my final slide. Actually.
Okay, one last question, if there is one. Okay, perfect then.
Okay, so 2 more slides. Learnings, conclusions. Purpose matters. I mean, that is also the question which just came up. It's like, what were you really trying to achieve? So when you go into any kind of threat intelligence project, selection, using, applying, think about what you want to achieve first, and think about how you measure success. What are the criteria that define good intelligence for you? How do you want to use that? And how do you measure whether you have achieved it? It's one of the most important things. Next thing is spend time reading the documentation and understanding what people and providers are actually giving you. So definitions matter. It's sort of a formal thing. Yeah, but I believe the timestamp examples clearly showed that you need to understand what's in there, and if it's called the same, it doesn't necessarily mean the same. So that's very important.
And also, I mean, it ties into the purpose one too. I mean, definitions on your side matter. Like, take time to define what does an APT IOC mean. Otherwise, it's just going to come and bite you 2 months into the project, 3 months into the project, when you're trying to have a conversation with someone and they're like, wait, why is this an APT IOC? So make sure you spend some time and agree on it, and maybe post it on the wall so that everyone knows what we're talking about.
Yeah. Also with the formats, I mean, I gave you this example of the nested XML in a zip file, transported via HTTPS with sort of the client-side certificate tied to IP addresses. Obviously, there's more to format, and I'm actually surprised no one asked about sticks or sticks too. I was expecting that question, or some question that named sticks somewhere. It is difficult to work with all these different formats, and you really need to, if you go into that, take into account that you will need engineering capabilities in a project.
Yeah, I mean, something we didn't get into was like, how did we actually work with them in the end? I mean, I work with Python, so in the end, I sort of extracted the labels that I thought meant, well, that were useful to us. Unfortunately, I had to dump quite a lot of the data that I couldn't quite fit into the table, and then build tables in Python and Jupyter notebooks and try and compare things like that. So it's not ideal, it's what we did.
Yeah. As I said, we tried the MISP approach first. That didn't work out, even though we do love MISP for a lot of purposes. For that purpose, it didn't help us. Accept that failure is part of the process. So try to be, open-minded to failure. That's another thing which is very important in here. Fail fast and learn. Maybe we should have failed a bit faster at one or the other point in time. And there is a lot of work to do on this part. I mean, that's basically what we were also showing with this presentation. There is a lot of work for research into, how do I actually measure quality of threat intelligence? So not only like the quantitative aspects, but really trying to understand the value and trying to understand the content that is being delivered. I believe there's a lot of room for doing good research on that part. How do you, for example, work with unlabeled data and try to get up with a maliciousness factor or an aptishness factor of unlabeled indicators? Would be a very nice research project. For users, I mean, we went a lot through the end user perspective or corporate user perspective. We all need to sort of think what we want to achieve. For vendors, I'm going to go to the vendor slide here. my last question, and OJ, that a little bit ties into what you're saying. Like, who is actually benefiting from this situation at the moment? It's definitely not us defenders who try to do better. We are not benefiting from this. Threat actors are benefiting from it because it's difficult for us to defend. And vendors benefit from it because for them it's easy to sell FUD, easy to sell file hashes as intelligence. So we all know this sort of term snake oil. Sometimes I have the feeling indicators, threat feeds, threat intelligence is a little bit like the new antivirus. It's like the new snake oil stuff that's out there being sold. So thank you. That's it.
Thank you very much.